Hello everyone, welcome to Java session. Today's topic is threads. In today's session, we will discuss about multitasking, overview of threads, thread creation, synchronization, thread transitions, and thread priorities, thread scheduler. Okay, now multitasking. Multitasking allows several activities to occur concurrently on the computer. So there are two different types of multitasking like process based multitasking and thread based multitasking. So, for example, what does it mean by process-based multitasking? Which allows multiple programs to run concurrently on the computer. The best example for process-based multitasking is like running the spreadsheet. I mean, it's like Microsoft Excel as well as Word at the same time. So on the computer, so you can switch back and forth from Excel file to a Word document. So these are the two different processes that are running on computer is known as process-based multitasking. Whereas a thread-based multitasking, which means within the same program, and there are two tasks simultaneously if run, then we call it as a thread-based multitasking. Like if we take the same word example word processor in which we can print and at the same time we can format the text. So these are the two different tasks which are being done in the same program is known as thread based multitasking. Next, overview of threads. So a thread is an independent sequential path of execution within a program. So this is a sequential path of an execution in a program is known as thread. So many threads can run concurrently within a program. So you can do simultaneous tasks simultaneously concurrently on the same program. So at runtime, threads in a program exist in a common memory space and can use both data and code. So they also share the process running in the program. So every thread in a Java is created and controlled by unique object of java.lang thread class. So threads makes the runtime environment asynchronous and allowing different tasks to perform concurrently. Uh, the main thread. So the runtime environment distinguishes between user threads and daemon threads as long as user thread is alive and the JVM doesn't terminate. So a daemon thread is the at the memory of the runtime system. If it is stopped at the mercy of runtime system, if it is stopped and if there are no more user threads running, then terminate the program. So these daemon threads exist only to serve user threads. So when standalone application is run, a user thread is automatically created to execute main method of an application. So this thread is called main thread. If no other threads are spawned, the program terminates when the main method finishes executing. So how we can create these threads? So a thread in Java is represented by a object of thread class. So implementing thread can be achieved in two ways. One is we can implement using runnable interface, which is part of java.lang package, and also we can extend the thread class. Okay, so we will see how we can implement the runnable interface. The runnable interface has the following specification comprising one abstract method declaration. So this interface is having one abstract method called run method. So whatever the class we are creating by using this runnable interface, we have to override this run method and do write the logic within the run method. Okay, so we have to build define the code in run method to execute the thread. So a thread ends when the run method ends. So either by normal completion or by throwing an uncut exception. So see here, spanning threads using runnable object. Current thread creates a runnable object runner, and when we create a new thread of runner, so thread when the starts. So what thread it will do? It will call the run method, and once it is executed, it will be ended. So there are the following summary of important constructors and methods from thread class. So we can use thread class by we can pass the runnable object, runnable thread target, and also runnable thread target and thread name. So we will see the examples on how to create a thread classes, how to create a classes using runnable interfaces and thread class, and also static thread, get current thread. So we have I mean like this is the static method from the thread class. By using get current thread, we can get the current thread, and which is also having name, get name, so it will give you the name of the current thread. And also set name, we can set the name of thread object. And also we can call the run method to execute the thread object. And the thread class implements the runnable interface by providing an implementation of the run method. So start is used to spans the new thread, that will begin execution of child thread of current threads. So extending the thread class. So a class can also extend the thread class to be created a thread. So a class extending the thread class overrides the run method from the thread class to define the code executed by the. So whatever the thread class we create, that can override the run method and implement our own business logic. So this subclass may call a thread constructor explicitly in the constructor to initialize the thread. So generally, when we create a thread constructor or constructor object in there itself only, we will initialize the thread and also will the start. Okay. So the start method inherited from the thread class is invoked in the object of class to make the thread eligible for running. So see here, a runner is there. So this is the runner object, and which extends the thread class, and it has start method and a run method. Okay, so once it is started, then it will execute the run method, whatever the logic we have in the run method, that will be executed. Next, so before going to the synchronization, we will see examples on these thread class and runnable interface. Here I have created class counter which implements runnable interface. Okay, so here in this runnable, so when we implement the runnable interface, we have to override that run method. So as it is an abstract method, so we'll have to implement that run method. Okay, so here I have taken current value, private integer current value, and in constructor counter we are setting value as 0. Okay, and we have a getter method, integer get value. And in run method, what we did is try catch block while current value is less than 5. So till current value is 5, we are printing system out println current name, so thread name, and current value we are incrementing. And this thread will sleep for 250 milliseconds. Okay, so this will sleep for 250 milliseconds and it will execute the while loop. Okay, and so if any interruption occurred, then it will be go into the interrupted exception E, and it is the exit of main method. Sorry, thread. Okay, counter thread. And for this we have written one client class. Okay, and here counter a equals to new counter object. And so in order to invoke this counter object, what we need to do is we have runnable interface, right? We have already seen. So thread class is having arguments like runnable interface, runnable object, as well as thread name. So what we did, like counter a comma this counter a, so it will print the worker dot start. So first of all, in order to execute this thread, what we need to do is, first of all we need to start. So worker dot start, and after that what we did here, value, so counter a dot get value. So what is the value of that thread? So while as it is a multitasking, so this counter will be running simultaneously. At the same time, we will see like what is the current value of that thread when we are executing this client main thread. So what does it mean by this parallel execution? Like we have a client thread which is running on main thread, and also counter thread. In the counter thread, what it is happening there, also it is executing. So in between, what we are doing is we are poking counter a thread and getting the value. So what is the value of counter a? So these are the multitasking. I mean, like one is printing the value, and second one is poking the counter thread and get the value. So there are two threads simultaneously running, and how it behaves we will see. Okay, and in both the threads, what we did, like we have sleep method called in both the client main thread as well as counter thread. Okay, We will see. So we will run this client application here, run as Java application. See here, first system.println worker. So what it did, counter A and 5 main. Okay, worker dot start. So counter value read by main. First of all, initial itself only it read the value, and then in counter A 0. So in counter what we are doing is counter A printing value 0, 1, 2, 3, 4. Exit from thread counter A. So at last, finally, again one more thread, this was invoked and it was 5. So at initially it was read, it read the value, and finally it read the value. And we can try multiple times, and we'll see. So first initially it read, and suppose we'll do 150 here. There we gave the 250, right, sleep time. Now every 150 milliseconds it will run. Right. Um, Run as, so like this 0, 1, 2, 3, 5. So we can uh, run these threads simultaneously and get the values. So this is using a runnable interface. There is one more class called thread counter, which is extending the thread class. So in thread class, we can pass the thread name as part of constructor argument, and in constructor itself only we can do the initialization as well as we can invoke the start method. So we will have to override the run method and the same logic. Okay, and here in thread counter A, counter B. So when we are creating the object counter A, it will automatically starts. So if thread counter client run as Java application. So there are two threads now. So method, first main method counter A 0, counter A 1, counter A 2, 3, 4. Then counter B started 1, 2, 3, 4. Exit from thread counter B and counter A. So like this, multiple threads can be spanned, and it can be started, and we can execute this business logic using these threads. So we'll go back to our next slide. Next concept is synchronization. So threads share the same memory space, that is they can share the resources. However, there are critical situations where it is desirable that only one thread can should access the shared resources. I mean, like suppose we have example as banking application. Okay, we have balance or amount. Okay, in amount field, if suppose someone is depositing from uh, one branch and another one is withdrawing from ATM. Okay, so two people are accessing on the same account on the same balance amount, so it should be synchronized. So if suppose one guy is, if it is not synchronized and two people are simultaneously accessing on the same account number and same branch, same amount, then you'll have issues with that those particular attributes, because if the amount is not there and if you are trying to withdraw, then what will happen? So what we need to do is we need to synchronize. So if someone is accessing a particular resource, then it should be locked, and the other thread cannot execute. So suppose if you are depositing, then that should be locked. So once it is completed, deposit is completed, then the other person can withdraw the money. So otherwise what will happen, you'll have the differences, so the amount will not be calculated properly, so you may see the discrepancies. So that's why we need to use, as multiple threads can execute simultaneously on a particular object. So those shared resources should be locked. So that is also called as monitor is used to synchronize shared resources. Okay, so thread gain access to a shared resource by first acquiring the lock, and then it will use the resources. And next is, so the object lock mechanism enforces the following rules of synchronization. So a thread must acquire the object lock associated with the shared resources before it can enter into the shared resource. So before it can access the deposit the money, so what we need to do is we need to that method itself should be locked. Okay, so the runtime system ensures that no other thread can enter a shared resources if another thread is already holds the object lock. So if someone is holding the lock, then the other object should not you know have access to that particular object. And when a thread exits the shared resource, the runtime system ensures that the object lock is relinquished. So if another thread is waiting for the object lock, they can try to acquire the lock in order to gain the access to the shared resource. So the keyword synchronized and lock mechanism from the form the basis of implementing synchronized execution of code. So there are two ways in which execution of code can be synchronized: by declaring synchronized methods or synchronized code blocks. Next, thread transitions. So thread states, a thread is having different states, like new state. First one is new state. So once thread has been created but it is not started, that is known as the new state. And a thread is started by calling the start method. So when we call the start method, then it is ready to run state. So it is ready for run state. A thread starts life in ready to run state. So running state, so if thread is running state, it means thread is currently executing. So if it is executing the run method, that is which is a running state. And dead state, once in this state, the thread cannot ever run again, so it will not run again. And we have various runnable state non-runnable states. So a running thread can transit to one of the non-runnable states depending on the circumstances. So if suppose if it is sleep, so if you call the sleep method, what it will do from running state to non-runnable state. So the thread sleeps for a specified amount of time. And blocked for IO, the threads wait for blocking operation to complete. And if you do any IO operations, that will be waited. And block for join completion, the thread awaits for completion of another thread to be executed, waiting for notification. Any thread is waiting for other threads completion, that is also waiting for notification. Blocked for lock acquisition, the thread waits to acquire the lock of an object. So when thread is created, it is a new state. So once it is started, ready to run state. So ready to run state. So when it is scheduled, running state. And if it is sleep or blocked for these things, these are all non-runnable states. So once thread is terminated, it will be in dead state. Okay. So you can check the state of the particular thread by using the get state method. So new created but not started. So whatever we discussed, the same. Runnable, blocked for lock acquisition, waiting state. So we have these constants available in thread dot state. Okay, these are the enum type: new, runnable, blocked, waiting, timed waiting, terminated. Okay. Next, thread priorities. So we have various priorities are there in thread. So if you want to bump the priority, so you can set those priorities. Like for minimum, we have three values. A minimum priority is 1, and max priority is 10, and default priority is normal priority 5. So if you want to increase the priority and this to be a particular thread to be executed at a highest priority, then you can set the maximum priority as 10. So those threads will be executed first. Thread scheduler. So schedulers in JVM implementations usually employ one of the following two strategies. One is a preemptive scheduling. If a thread with higher priority than current thread running, then thread moves ready to run state. The current running thread can be preempted to let the higher priority thread execute. So if any other higher thread priority comes, then the current thread will be ready to go back to the ready to run state. And time sliced or round robin scheduling, like if we have multiple threads are executing fixed length of time, which will move from ready to run to running and running to ready to run states. So and sleeping, so if you put sleep for some certain time, it will be sleep and other threads will be executed. Like this, it will move from ready to run state and running state. And if suppose uh, any one particular method is synchronized and it is executing, the other threads will be waited. So once that has been completed, it will notify the other threads to acquire the lock, like that. So we can use wait, notify all methods of object. Okay, class. So like this, thread scheduler can be used. So if we have any queries on today's session, please mail us at info@bicourses.com. We are happy to answer your queries and questions. Thank you so much.